Inverse variation. So before I explain what inverse variation is, let me remind you of what direct variation is. So if y varies directly with x, then y equals kx. So now, inverse variation, if y varies inversely with x, then y equals k over x. So for example, suppose x and y vary inversely, and x equals 4 when y equals 12. First, what function models the inverse variation? So the first thing we're going to do is write the general equation, y equals k over x, and then we will substitute for x and y. So y is 12, x is 4, so 12 equals k over 4, and then solve for k. So I'll multiply both sides by 4, and I get k equals 48. So our function that models the inverse variation is y equals 48 over x. Part B, what is y when x equals 10? So let's take our y equals 48 over x. Let's substitute in for x. So y equals 48 over 10, which is 4.8. So y equals 4.8 when x equals 10. We can also have inverse variation with powers. So if y varies inversely with the nth power of x, then y equals k over x to the n. So for example, y varies inversely as the square of x, and y equals 40 when x equals 1/2. So let's find our function that models this. So in general, here we've got y equals k over x squared because y varies inversely with the square of x. So let's substitute in what we know. We know y is 40, x is 1/2. So 40 equals k over 1/2 squared, or 40 equals k over 1/4. And now let's solve for k by multiplying both sides by 1/4. 1/4 of 40 is 10, and on the right side we have k, so k equals 10. So our function that models this is y equals 10 over x squared.